Alright, so let us continue on optimizing sequential code. So, you are not really parallelizing it, but sequential code itself can be made reasonably fast, right. We saw various tricks. Simplest thing is just give compiler option, and second thing is worry about the loop, vectorize it, and then you get a very good speed up. But now let us look at one more issue, which is based on cache. So, in the last several classes we had loop which was I and j, 2 loops, right. Now, suppose you have 3 loops I, j, k with matrix only. So, I am going to illustrate using an example how cache becomes important for speed up, and this was done in Colab with O fast option. I think only one O option. Okay, I think both O3 and O fast options. So, this is matrix multiplication. So, we have C equal to matrix C is A star B. So, how do I write this? How do I compute this? So, C I j is A I k B k j is sum over k is, right. Now, the most obvious thing which any student would do, or anybody, I would also do it, is make 3 loops I j k, and k will be the innermost loop, right. So, this is just translation of this formula. Okay, so, let us look at the timings, what time we get. We get 3 minutes 53 seconds, I have 4 minutes. O fast gives you 6.9 seconds. Okay, but okay, so this is what we get. Now, I just change the order. So, instead of I j k, I make it I k j. Okay, we just change the order. So, it is the same formula, but the loop order was changed, and the numbers are O fast is wait a minute, did I make a mistake, 6.51 seconds, and this is 6.98 seconds. Okay. This is what we get for these two cases. Actually, there is something is let me just go ahead. The third case is k I j. K I j is you make k at the top, and the numbers with O3 is 6.989 seconds. Compare this with O3 was 53 seconds, and this was, so first was O3 is worst, but the O fast is doing some arrangement within itself. Okay, O fast is very clever. It is worrying about cache alignment. So, O fast is very clever. O3, you can see, focus on O3 time. O3 is not changing the loops. First one is 53 seconds, second one is 3 minutes 53 seconds, second one is 3 minutes 6.4 seconds, sorry 6.44 seconds. I am making a mistake, this O3 I am counting as minutes. So, let us do it from beginning. Okay. So, I am going to cut this part. So, let us do from the beginning. So, we are doing matrix multiplication C equal to A star B. So, multiply 2 matrices A and B. So, the formula is matrix multiplication is C I j is A I k B k j sum over all k's. So, I need to compute it for every I and j, and for that I need to sum over all k's. So, there are 3 loops. So, I j k, the 3 loops I j k, n is the matrix size, n squared is the matrix size, and we write like this. So, I did this for 2048 squared matrix, and the timing with O3 option, this colon is not the timing, O3 option is 53 seconds, 53.1812 seconds, 53 seconds. Okay. O fast is 6.98 seconds. I switch the order. So, I make it I k j, then time has come down in O3 option is 6.4 compared to 53. How much factor? 9 times, just by changing the order of the loop, and O fast remains roughly the same. Okay. So, O fast, the O fast has already done something, for the first loop, first example. Now, let us change this loop further to Kij, okay, and Kij timings are 6.9 and 6.88. So, first one is bad with O3, and normally people use O3, but it is going to give you some interesting insights. But OFAST takes care of, does some clever thing, and it gives you reasonably same timings. So, let us see what happens inside. So, IJK, IKJ and KIJ. Okay. So, we are computing C, right, this is C matrix which is product of A and B. So, AIK and BKJ. How are these elements stored? Is a C or Python program. So, it is going to be stored as row major, means the allocation will go like this. The first one will be this, second, third, fourth, fifth, sixth, 7, 8 like this. Okay. So, this sixth element will be, so by the way, as I said, all these 2D arrays are stored as a single 1D arrays. You can have 4-dimensional arrays in C or Python, it is going to be stretched into a single 1D array. Okay. 3D, what will I do? I do plane by plane, and every plane I follow this row major sequence. All right. I think this is understandable. You have done enough programming, so you know that. So, this element will be 0, 1, 2, 3, 4, 5. So, this is fifth in C notation. In our usual day to day life notation will be 6, but in programming language start with 0. 0 is a valid address. So, start with 0, then that will be 5 in 1D. Now, so AIK I store, so I am doing this. So, AIK is, so I am going to, compute this, I is, what is I? I is 1, right, 0, 1, I equal to 1, I equal to 1. No, this is the first in C notation. And what is J? J is also 1, right. So, this is J. So, J is also 1. So, when I am computing this blue element of C, I had to keep I and J fixed for. So, for A I will be fixed, which is 1, first row, but I have some overall case, and for B I have to fix J, which is column has to be fixed, and I vary K. Okay. So, you can see where are the elements which has to be multiplied and added. So, this green strip of A and the red strip of B will be element multiplication and then add. So, look at how A array is stored. Actually, A array of course is stored, all the 16 elements are stored in a single 1D strip, but the 4 elements will be stored consecutively side by side, right. This is will be in C, it will be 4, 5, 6, 7. So, the 4, 5, 6, 7, the 4 elements. But what about B? How will B be stored? So, I go again row major. So, this will be stored first, then second, or 0, 1. So, 0, 1 is this first element, this is coming here. Second element, where is stored? I have to skip all the way, this it is going to be the C 5, location 5. So, this is location 5. So, element 2 is here, element 3 is here, element 4 is here. Okay. Now, I am illustrating using how many data points? 16 data points. Imagine I have 2048 squared. So, the gap will be how much? 2048. So, what does memory do? It sends a chunk of data cache. It is quite likely that 1 and 2 will not be simultaneously fetched from memory by cache. You get it? So, when it does the loop for the K loop, right, remember this is what I am doing. I am looking for linear most loop. and I want to compute this. So, the computer says, well, I want to multiply this with this with this, okay. But the first one is done, okay, first one is done because this is already obtained. This is multiplied by this. This is to be multiplied by plus this one, but this element 2 is not there in the memory for B. So, what is it going to do? Well, tell no data, go and fetch this element of B. But once this is done, then what? It goes to the third element, this one, and here again third element is absent in the cache, it is far away in memory. So, that is the problem, it is getting data from the memory and it is not doing it efficiently, right. Your data whatever you need should be close by, so that there is a cache hit. Cache miss is bad actually, okay. Because cache is the closest memory and you want your current data to be in the cache. Okay. So, that is why the IJK is a worst loop sequence and it takes around 53 seconds. Now, let us look at next one. This is IKJ, you can see this IKJ. Now, so this is the tricky part. So, this is why these guys are very clever who think about all these possibilities. So, presently I am fixing I and k. Okay. K is a second loop. Okay. So, let us fix I. I am going to fix I to be here, which is I equal to 1. K is put here as k equal to 3. K equal to 2, sorry, this k column, no, I am making a mistake. I equal to 2, I equal to 1, I equal to 1, I equal to 1, and k is a second one, which is okay. So, j is varying, right now j is varying, j is going from 0 to 3. Okay. I am varying k slowly, I is the slowest varying, but varying k slowly. So, this is k equal to 2. So, what I do is I take this element, this this k equal to 2 element, this is fixed element, because k is fixed to 2 and I vary j, I vary this j. Okay. So, j is a column of B, I hope you are following me, j is column B. So, I just take the column of B and multiply this with A, one element of A. So, this one element of A is multiplied to all the 4 elements of B. Okay, that is what it is going to be doing in this loop, because j is varying. Now, so I am going to write this whatever I get to C. So, the results whatever multiply is written to C, but is going to, so this is going to be the 4 numbers are going to be updated, but it is plus equal to, because I need to add for every k. So, next time k will be moving here. So, the k next k will be here. Okay. Then again I multiply this by these elements and add them there, because that is why this plus sign is there, this plus sign. But adding is not a big issue. Once you have the data, you can just multiply. These are all vectorized operations. So, I can just take this product will be stored somewhere in this 4 elements and that will be just added here, just add to this. But data what you need should be consecutive and it should be in the cache. Okay. So, that is why this operation is faster. I hope this is clear. Now, let us look at the third example, Kij. Now, you just focus on what are you varying, what you are varying slowly, what you are varying fastest. So, here j is the varying fastest, j is varying fast, and right, and k is varying slowest. Okay. So, what I am going to do here, I am just going to fix one of the a's. is pretty similar to the second one. So, this is A I k, okay, and you multiply and add. So, this one is pretty similar to what I did in the last one. So, it is just that the loop has been changed, it is going to be updating this, but in the last example, my variable my A was varying like that. Okay. In the next example, my A is varying like this, which is not the best thing, because next A has to come again from cache, from memory. This will be far away. Okay. This was better if you on comparison, that this A will be in the next one. I multiply and add there. So, I would say that this is not the, but the timings are not too bad. O3 is giving reasonably good time. Okay. So, cache is also not very big. So, when I do the next loop, anyway I had to get the data. So, I get it from the RAM. So, it depends on the cache size. If cache is big, then these issues will not occur. Well, this still will occur, because vectorization to fetch data which are distant data and make a vector is time consuming, but rather it is not the best thing to do. Your data should be consecutive. Okay. So, this one I took from a blog. This is the blog by Brihadaswaran. Okay. So, this is done, of course, in this some different machine. So, we did IJK, IKJ and KIJ. These three I did not present, but you can try yourself. You just have to change the loop and get the numbers. This is the well, I mean, among, for us this was the worst, this is the best. No, KIJ, sorry, I did KIJ, not KJ. I did KIJ, no, the last one was KIJ. KIJ. So, I did these three, 1, 2, 3, and these two numbers are roughly the same, and others are bad. Okay. Now, it is a good thing to ponder over why they are bad. So, this is the importance of using cache in the best possible way.